Hi everyone, welcome to the Julia conference. Proc GenMod in SAS and RGLM are two most popular modules in statistics, and both are in place since last 2 decades. GLM in Julia is comparatively new. We did some comparative studies in the beginning of the year 2022. Let us present some of them one by one. Two main aspects of a generalized linear model are distribution family and link functions. Let's see where Julia GLM is positioned right now. Except geometric distribution, almost all one-parameter exponential distributions are available in Julia. But geometric distribution is the special case of negative binomial distribution. So one can do modeling with geometric distribution indirectly. But R and SAS both have bigger ecosystem than generalized linear model. There are many extensions of R's GLM, especially zero inflated models, and 3D, are not available in Julia, at least a stable version. The list of link functions is quite impressive. The one and only missing link function is power link. The power function defines the class of transforms that use a power function or logarithmic function as it is shown here. Many existing link functions are a special case of power link. For example, it is identity link when lambda is 1, it is square root link when lambda is zero point 0.5, it is log link when lambda is 0, it is inverse link when lambda is minus 1, it is inverse square link when lambda is minus 2. The benefit of having power link is we can find optimal lambda value using some optimization methods, especially some heuristic methods. The example shows here a way to find optimal value based on BIC. One can use any other method like AIC, AICC, log likelihood, etc. to get the same. Now let us see how Julia GLM performs with some extreme data. This is a dataset or table I used to torture the numerical routines I have written. I have inherited the dataset from Professor L. Wilkinson, the author of Grammar of Graphics book. If we look at the data carefully, we can observe the relation between variable x and tiny. Variable x can be expressed as 1e to l times of tiny. If we want to perform a linear regression with intercept where x is a dependent variable and tiny is the independent variable, like x equal to a plus b times tiny, then we should have 0 as the estimate of a and 1e12 as the estimate of b. Unfortunately, Julia LM produces something else, whereas R produces correct one. Now let us extract model matrix M and response vector Y and calculate M prime M inverse times M prime Y. These matrix operations give estimates of linear model. These estimates are correct. Julia GLM uses Cholesky decomposition, which is very fast compared to QR decomposition or SVD decomposition, but less accurate, especially for ill-conditioned data. Okay, for huge variable, both R and Julia GLM calculate same and estimate correctly. NIST, National Institute of Standards and Technology, archived a set of 11 datasets with corresponding linear model and certified estimates. NIST claimed that certified values are accurate till last decimal places. We have tested both R and Julia LM functions with these datasets. Now let us take one from the list, which is no int 1, a dataset where corresponding model does not have any intercept term. We can see both R and Julia produce same estimates, and the estimates are matched with the certified value. In case of R squared, R matches with certified value, but Julia unfortunately produces a negative value. This has been corrected in the latest release, V1, version 1.8. Now let us compare the performance. To have an idea about the performance of Julia GLM, we have performed a logistic regression with 50 independent variables and approximately 3.5 million rows. We have tested the performance in Linux machine with these configurations. Based on 20 evaluations, the median time for Julia is approximately 5 times faster than the median time for R. This is not only because of Cholesky decomposition, but Julia GLM utilizes maximum possible resources. As we all know, the computational backbone of Julia is very strong. The following are our contributions to Julia GLM. We have added power link function and geometric distribution. We have corrected some functionalities in GLM for models with no intercept so that it produces correct metric like R square. We have also tried to improve readability of GLM documentation. Right now, multicollinearity is handled only in LM function using the keyword argument drop collinear. Still, GLM function throws an error if there is multicollinearity in the dataset. We have raised a pull request to incorporate drop collinear feature in GLM function like LM function. We are grateful to the Julia Stat community, especially to Mr. Milan, for making these PRs successes.